Hi, Java programmers. Today we're going to learn about equals and hashcode. These two functions are pretty important. And when I first started Java programming, I didn't have to use these two functions initially, but until one day I had to start using some collections. Then I encountered some behaviors that I didn't expect. Then I realized that, oh, it has something to do with these two functions. So I'm just gonna give you a quick demo, and hopefully by the end of this tutorial you will you'll be the expert of this equals and hash code functions. Okay, let's just jump in right away. Here I have a very simple Pojo called person. A person has a minimum set of properties: first name, last name, social security number, and it's immutable. So constructor getters, no setters. Okay, so imagine you are implementing a company directory, and you are having this in-memory database. Let's say you're using a list, and you want to enforce this policy that we don't want to have two employees having the same name and the social security number. So you can go about doing that by doing this simple check whenever a new employee gets on board and being added into your list. Then you can do this traversal of the list, and for each and every element you check the equality against your newly onboarded employee and make sure that they don't have the same name and social security number. Hopefully you understand that this is not a good place to use the double equals check, because that checks the reference instead of the identity. Basically, it checks to see if two pointers points to the same object instead of checking the contents of the object. So let's just start doing some experimentation here, creating a main function, and then let's start creating some objects. So P1, let's call this guy John Smith. I'm not very creative on this. Okay, so John Smith, and I say John. So we have created two person objects, and they happen to have the same set of properties. Okay, this is exactly the situation we want to avoid. We don't want to have duplicate identities, right? So in that case, you want to have your checking return or catch this situation, and being able to identify that P1 and P2 are equal. So let's just print out P1 dot equals P2. Are they equal? I'm gonna give you an answer by calling P1 equals P2, right? But at this point, we haven't overrode equals function. So this is still taking the default behavior from the object class, which is the grandfather class for all Java classes. Let's take a look at the default implementation. This is basically doing a reference check against the other object. Okay, in our case, P1 and P2 points to two different objects, so this will return false, which we can check by running this. Okay, P1, P2 are not equal. Okay, not the behavior that we are expecting. So straightforwardly, we have to override the equals function. and provide our own behavior. First, we have to do some sanity check and catch some edge cases. If object is null, of course, we are going to return false. Or if the object is not even an object, is not even a person, is not an instance of person, return false. So now we know that object is a person, we can cast it to a person. And we return true if and only if all of the properties are equal. So first name is going to be equal case insensitive to p2.get first name. And same thing for last name. Get last name. Okay. And also social security number. This is a primitive type, so primitive type, so we can use the double equals to do the checking. So p2.get social security number. Okay, cool. So now we have equals implemented, and we should expect this to be true. Just to make this complete, we create a third person with a slightly different name. Let's say Bob Smith. Bob Smith. Okay. So Bob Smith, is that the same as John Smith? Let's do the checking. Okay, so we should expect P1 and P2 to be equal, but P1 and P3 to be unequal. Okay, let's run this. Okay, so true and false. Okay, cool. Everything makes sense so far. Not very interesting, but as I mentioned, you probably don't want to implement this as a list because that's linear complexity whenever you insert a new employee, which is not very good. We know that there is another data structure that we can use, which performs better, which is going to be a hash map, right? Or a hash map. So how does a hash or a hash set, in our case, because we don't want to use a map, how does a hash set enforce this, uniqueness of all the members of the collection? So internally, what it does is that for every object that you insert into the collection, it first computes the bucket that object needs to go into, and the bucket is going to be identified by the object's hash code, which we'll get into later. And then it will just going to be some kind of linear data structure to store all the objects into that bucket. Basically, this is what we call sharding, and we are partitioning the collection space into a lot of buckets so that hopefully we're trying to be a little bit smarter. We don't have to traverse the entire set every single time. We just first hash and find out the bucket, and then we have a very compact data collection or collection that we can work on in that case. So the question is, what if two objects will, let's say two objects, they happen to have the same hash code, which is, likely. That is what we call a hash collision. So what happens in that case? So they hash to the same bucket, and the next thing we do to make sure data uniqueness is by calling the equals function that we just implemented. So that is still a lot better than linear, hopefully, because hopefully by the time of doing all the hashing, the bucket size will be substantially smaller. than the overall collection size. That's the idea. So let's take a look at this hashcode function. In that case, let's first create a set. Okay, a set of person, and we are going to use hash set in our case, and we say we want to add our employees into our set. Let's just duplicate it a whole bunch of times, and for demo purpose, let's say we somehow add P1 twice, and we also add P2 and P3 into our set. So, and we want to print out to see now how many elements do we have in our set. So we can get that by calling the set.size function. Okay, cool. Now, what is the expected behavior in our case? Since we haven't implemented our hashcode function, we should expect this to be a no-op because you know, P1 is P1 and they generate the same hash code, so same bucket and the same equals identity. However, P2 and P3, they are two completely different objects, which most likely they will generate a completely different hash code. A hash code is just an integer, right? An integer is 32 bits, so which means that we have how many unique possible buckets? That is 32 bits, so that's like 4 billion slots, right? So imagine we have a pretty good hash function, then after 4 billion insertions, we not after 4 billion insertions do we have collision situation going on. So this is highly unlikely that P2 and P3 are going to be collide with each other. Anyways, that's just how hash function works. But anyways, so we should expect this to be 3 by now. Okay, so we verify that, which is not expected behavior for our application. We want to have the hash set catch the duplicate cases. So now we have to implement hashcode. So hashcode needs to take into consideration of all of our object properties. So we can use this handy tool or utility function provided by the objects class. So this function takes in an array basically, and you can create whatever array that you want, and that will just going to generate a unique identity, a unique hash code for that particular array. And in our case, we just throw in all of our properties for that class. And we are going to return this. Okay. So now, since P2 and P1 have the same set of properties, we should expect them to generate the same hash code. So they should hash the same bucket. Also, as we already tested, P1 and P2 are going to be equal, which means that the hash set should declare that P2 is a duplicate of P1, so this should now be a no-op. Whereas for P3, this will again going to generate a completely different hash code. So we should end up with 2 elements in our hash set. Let's just verify that. Okay, cool. That is what we want, and that is pretty much what I want to show you guys, and hopefully you get a hang of what's going on here. And just the rule of thumb for when you need to implement equals in the hash code. So first of all, if two objects are equal, then you definitely need to override hash code as well, because they should be the same. However, if two objects have the same hash code, then they not necessarily have to be equal, which makes sense, right? Okay, that completes my tutorial, and I'll see you next time.